right now, at this very moment, something is ripping through our solar system at 137,000 miles per hour. It's older than Earth, older than the Sun, older than everything you've ever known. And 3 months ago, we had absolutely no idea it existed. But here's what's blowing scientists' minds. This thing started glowing in the cold, dead darkness of space, in a place where it should be impossible for anything to happen. And when astronomers calculated where it came from, they realized it's not from here. It's not from our solar system. It came from another star. This is 3I/ATLAS, and it's breaking every single rule we thought we knew about comets. So let's start at the beginning. July 1st, 2025. Chile, a telescope called ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, was doing its usual job of scanning the sky for potential threats to Earth. And then it spotted something. Something moving, something fast. Really fast. At first, astronomers didn't know what they were looking at. Was it an asteroid? Was it a comet? All they knew was that this object was racing through space at approximately 137,000 miles per hour. To put that in perspective, that's about 180 times faster than a speeding bullet. But here's where things got interesting. When astronomers traced the object's path backward, they realized something incredible. This thing didn't come from our solar system. Think about that for a second. Everything you've ever seen in the night sky, every planet, every asteroid, every comet, was born in our solar system about 4.6 billion years ago from the same giant cloud of gas and dust. We all share the same cosmic family tree, but not this visitor. This was a true outsider. Within days, observatories around the world turned their telescopes toward this mysterious object. The Canada-France-Hawaii telescope, the Loeb Discovery Telescope, even amateur astronomers started capturing images. And what they saw confirmed it. This wasn't just any space rock, it had a coma. That fuzzy cloud of gas and dust that tells us we're looking at a comet. On July 2nd, 2025, it became official. The International Astronomical Union gave it the designation 3I/ATLAS. The I stands for interstellar. The 3 means it's only the third interstellar object we've ever detected visiting our solar system. Only the third, ever. The first was Oumuamua in 2017, that weird cigar-shaped object that sparked all kinds of wild theories. The second was Comet 2 I/Borisov in 2019. And now we have 3I/ATLAS. But unlike its predecessors, 3I/ATLAS was about to do something that would leave scientists scratching their heads. Here's where our story gets really weird. Comets are basically dirty snowballs, chunks of ice, rock, and frozen gases that have been preserved in deep freeze for billions of years. When they get close to the sun, the heat causes the ice to turn directly into gas in a process called sublimation. This creates the beautiful tail we associate with comets. The key word there is close to the sun. Most comets don't start doing anything interesting until they get inside Jupiter's orbit. That's about 5 astronomical units from the sun. 1 astronomical unit, or AU, is the distance from Earth to the sun, roughly 93 million miles. So we're talking about comets that need to be within about 465 million miles of the sun before they wake up and start their show. But 3I/ATLAS? It started glowing when it was 6.4 astronomical units away from the sun. Let me repeat that because it's crucial. This comet started producing a visible coma and showing activity when it was farther from the sun than Jupiter. At a distance where it should have been cold, dark, and completely dormant. Professor Jacqueline McCleary from Northeastern University put it perfectly when she said this was abnormal enough that some people initially thought it might be an alien spacecraft. What else, small and quick, would be producing its own light that far from the sun? Now, before you get too excited about aliens, we've figured out what's actually happening. But trust me, The real explanation is just as fascinating. NASA's James Webb Space Telescope, the most powerful space telescope ever built, turned its infrared eyes toward 3I/ATLAS. And what it found was remarkable. This comet is absolutely loaded with carbon dioxide, dry ice. And here's the thing about dry ice. It doesn't need much heat to sublimate. You've probably seen dry ice smoking at room temperature. It turns from solid to gas very easily compared to water ice. So while regular comets need to get close to the sun to start melting their water ice, 3I/ATLAS's carbon dioxide ice was already turning to gas way out in the cold depths of space. But why does it have so much carbon dioxide? That's where things get even more interesting. Scientists believe 3I/ATLAS formed in the extremely cold outer regions of another star system, a place where temperatures were cold enough for carbon dioxide to freeze solid. We're talking about regions potentially even colder and more distant than our own Kuiper Belt, where Pluto hangs out. The Hubble Space Telescope captured stunning images of 3I/ATLAS, showing a teardrop-shaped cocoon of dust streaming off its nucleus. It was producing this beautiful coma and even developing a tail when most comets would still be nothing more than dark, frozen rocks invisible against the blackness of space. This has never been observed before in a comet. Let's talk about speed, because 3I/ATLAS isn't just unusual. It's a cosmic speed demon. Remember those other two interstellar visitors I mentioned? Oumuamua was zipping along at about 58,000 miles per hour relative to the Sun. 2I/Borisov was moving at roughly 72,000 miles per hour. 3I/ATLAS. Question mark, it's traveling at 137,000 miles per hour. That's almost twice as fast as 2I/Borisov, and more than twice as fast as Oumuamua. This thing is absolutely screaming through our solar system. To give you some perspective, if you could somehow travel at this speed, you could go from New York to Los Angeles in about 72 seconds. You could circle the entire Earth in just over 3 minutes. But here's what makes this speed so scientifically significant. It tells us something profound about where this comet came from and how long it's been traveling. The faster an interstellar object is moving when it enters our solar system, the longer it's potentially been drifting through space. That incredible velocity didn't come from nowhere. It's the accumulated result of gravitational interactions, possibly being flung out of its home star system by a close encounter with a giant planet, then spending eons accelerating through the galaxy. Some estimates suggest 3I/ATLAS could be 10 billion years old. Think about that. 10 billion years. Our sun is only 4.6 billion years old. Our entire solar system, Earth, the planets, everything, is younger than this comet. 3I/ATLAS might have formed when our galaxy was young, when the universe itself was less than a third of its current age. This comet is literally older than our world. The speed also tells us something else. This object came from either the Milky Way's thick disk or thin disk, two different populations of stars with different ages and compositions. If it came from the thick disk, that would support the idea that it's ancient, possibly one of the oldest objects humanity has ever directly observed. When the James Webb Space Telescope analyzed the light coming from 3I/ATLAS, it wasn't just looking at a pretty picture, it was reading the comet's chemical fingerprint. And that fingerprint is telling us an incredible story. The observations revealed that 3I/ATLAS contains carbon dioxide, lots of it, water ice and water vapor, but surprisingly little, carbon monoxide, carbonyl sulfide, cyanide gas, atomic nickel vapor. Now that last one, nickel vapor, is particularly fascinating. When the Very Large Telescope in Chile analyzed 3I/ATLAS, it detected atomic nickel being released from the comet. This is actually similar to what we see in comets from our own solar system, but finding it in an interstellar comet gives us a crucial data point. It suggests that comet formation processes might be similar across different star systems. But it's the ratio of these chemicals that's really interesting. 3I/ATLAS has way more carbon dioxide relative to water than most comets we're used to seeing. This isn't just a minor difference, it's a major compositional signature that tells us about the environment where this comet formed. In our solar system, comets generally formed in regions where water ice was the dominant frozen material. But 3I/ATLAS, it formed somewhere colder, somewhere more distant from its parent star, where carbon dioxide could freeze solid and remain the dominant ice. This gives us a window into another solar system. A system we can't visit, a system we can't even see, but a system we can study through this ancient messenger that escaped its gravity billions of years ago. Every gas molecule released from 3I/ATLAS, every photon of light reflected from its surface, is a clue about conditions in a planetary system so distant that its light might not even reach us for millions of years, or might have stopped shining long ago. Scientists are also learning about the comet's size. Initial estimates suggested it could be as large as 12 miles across, but as better data came in from Hubble and other telescopes, that estimate dropped. Current measurements suggest the nucleus, the solid icy core, is probably between 1,400 feet and 3.5 miles in diameter. Still a substantial chunk of ice and rock, but smaller than initially thought. Let's zoom out for a moment and think about what 3I/ATLAS represents in the bigger cosmic picture. Our solar system isn't isolated. We're part of a galaxy containing 200 to 400 billion stars, and many of those stars have their own planetary systems. When giant planets form in these systems, their powerful gravity can fling smaller objects, comets, asteroids, planetesimals, out into interstellar space. For every star system that forms, countless objects are ejected, becoming interstellar wanderers. Some estimates suggest there could be more interstellar objects in the galaxy than there are stars. These objects become cosmic nomads, drifting through the darkness for millions or billions of years. Most will never encounter another star system. They'll just keep floating through the emptiness forever. But some, by pure chance, pass through other star systems. They get a brief moment in the light, a few months of warmth and attention before returning to the cold darkness of interstellar space. 3I/ATLAS is having its moment right now. After potentially 10 billion years of solitary darkness, it's experiencing the light and warmth of our sun for a brief cosmic instant. And we're here to witness it. That's kind of poetic when you think about it. But there's also something profound here about perspective. This comet has traveled for billions of years, crossing unimaginable distances through the void. It might have passed by countless other stars, unseen and unnoticed. It formed in a stellar system we'll never see, under conditions we can only infer from its chemistry. And now, for just this moment, its path intersects with ours. A civilization on Earth, barely 300,000 years old, with telescopes that have existed for only 400 years, managed to spot this ancient traveler and decode its secrets. It's a reminder of how vast the universe is, how ancient it is, and how much is happening out there beyond our tiny corner of space. But it's also a reminder of how far we've come in our ability to understand that universe. So what happens now? Astronomers around the world are still watching 3I/ATLAS as it continues its journey through our solar system. Even though it's currently difficult to observe from Earth due to its position relative to the Sun, spacecraft at Mars and the upcoming observations from JUICE will continue gathering data. Scientists are particularly interested in how the comet's activity changes. As it gets closer to the Sun and then moves away again, how does its brightness and gas production change? This tells us about what kinds of ices are present and at what depths. Its exact size and shape. Better measurements will help us understand not just this comet, but the population of interstellar objects in general. What do you think is the most amazing thing about 3I/ATLAS? And what would you want to know if we could send a spacecraft to intercept an interstellar object? Let me know in the comments, and if you found this fascinating, make sure to like and subscribe.